Hello and good afternoon. My name is Nancy Seidman, and I am a Senior Advisor at the Regulatory Assistance Project. I am the moderator for today's webinar. Welcome to today's webinar on eMERGE, a process integrating state and local energy and environmental regulation and planning to promote clean air and clean energy. eMERGE provides a unique opportunity for environmental and energy agencies to work together planning for a clean energy future while including an area's environmental goals and requirements. We are recording today's session for anyone who would like to watch the webinar again or misses today's session. We'll send a link to the recording and the slide deck to all registrants in the next day or so. With more than 200 participants with us today, we'll keep your phone lines muted during the webinar. We look forward to your questions and ask that you please type them into the questions pane on your GoToWebinar control panel, which is located on the right side of your screen. Next slide, please. The panel is on the slide you're seeing now. We will pause the presentation for brief clarifying questions and will address all other questions during the Q&A session after the presentation. The official portion of the webinar ends at the top of the hour, but we will stay on the line for up to an additional 30 minutes for anyone who has additional questions and would like to continue the discussion. Next slide, please. Now I'd like to introduce today's webinar presenters. First, Ken Colburn. Ken Colburn is a principal at RAP. He advises energy and environmental regulators on air quality and climate-related issues, as well as on opportunities associated with regulatory compliance, energy efficiency, renewable energy, distributed generation, integrated resource planning, and other energy policy matters. Ken's efforts currently focus on streamlining energy and environmental regulation and beneficial electrification. Second, Chris James. Chris is also a principal at RAP. He advises regulators, advocates, and businesses on how to reduce greenhouse gases, criteria, and toxic pollutants to meet existing and new air standards, improve water quality, and protect consumers. His projects span the areas of air quality, energy efficiency, distributed resources, demand response, and linking energy and the environment in air quality and energy planning processes. And with now, I'll turn it over to Chris to start the presentation.
I think Nancy, Ken's going to kick it off.
Okay, sorry. Go ahead, Ken.
No
Thank
problem.
you. Please begin.
You bet. We've characterized this webinar and our related blog posts as retooling and used this graphic because it's a good characterization of changes occurring in the power sector itself and regulation there. Our society has utilized the hand tools and electric machine tools of yesteryear for generations, but over the last 2 or 3 decades, computer-controlled machine tools have taken over. And these tools all removed material in order to reveal the product within, but today we're witnessing real game-changing technologies called additive manufacturing or 3D printing that can actually print a product layer by layer. Well, we've seen a similar evolution in the power sector from simple to complex centralized generation and grid systems, and today we're witnessing game-changing clean distributed energy resources, microgrids, communication systems, and numerous other technologies. So why is retooling needed now? Well, it's because today's energy and environmental regulatory paradigms need retooling to take advantage of today's new technology opportunities, just as yesterday's manufacturing paradigms did. Let's take a closer look at why. First, utility regulation has become far more difficult and uncertain. The power sector is swiftly transforming, largely due to new and better technologies and software for both the supply side and the load side, demand side. Renewable energy and distributed energy resources are certainly chief among them, but storage, beneficial electrification, analytics or big data, grid management, microgrids, Internet of Things, blockchains, the list hardly ends. They're all playing key roles too. For example, load factor used to be the holy grail in grid management. Now it's flexibility instead. In other words, not capacity factor, but response time. And a telling example of this transition in difficulty is how can utility regulators assess project prudency, investment prudency over 20 plus years with any confidence under today's conditions of rapid change. The situation's similar over on the air quality and climate regulation side. It's become increasingly difficult as well. The Clean Air Act has secured remarkable public health achievements, but after almost 50 years, it too is showing signs of age. Today, we recognize that controlling emissions of various pollutants can have interactive effects, positive or negative, yet the Clean Air Act strictly prescribes serial pollutant by pollutant regulation. And also, the health science that underpins the determination of air quality standards has itself rapidly advanced. Under the Clean Air Act, EPA is obligated to adopt standards that provide an adequate margin of safety. But how can it do so when modern detection technologies show linear pollutant impacts all the way down to zero? There is no bend in the curve anymore that EPA can aim at. And to top this off, in the midst of this disruption, energy and air quality and climate policies now impact each other more than ever. I'm fond of the quote of Francis Cairncross, former editor at The Economist, who put it, and I'm paraphrasing, that energy has the greatest impact on the environment and public health of any other human endeavor. And then at the same time, as we all know, EPA has recently been characterized as overreaching and trying to determine U.S. energy policy. So clearly there's direct overlap more than ever. Let's look at some examples of these disruptive elements. This chart shows how dramatically GDP and energy have been de-linked. For a long time they moved in lockstep with each other, but as a result of greater energy productivity and efficiency, you can see that GDP has soared while energy has remained relatively level. Flat or declining CO2 emissions are also not surprising when you look at recent developments on the supply side of U.S. generating capacity. For the last several years, more than half of all new generating capacity added to the U.S. grid, that is to say new power plants, if you will, has been renewable resources, primarily wind and solar. Further evidence of these resource changes are clear in this graphic, which looks busy, but it tells a big story. It shows overall energy inflows on the left, the uses to which the energy is put in the middle, and on the right. This particular chart shows, was done by the Vermont Public Service Department, shows massive changes between 2015 and 2050. And in particular, the decline in fossil inputs at the left, and a parallel increase in renewables and bioenergy inputs. And then over on the right, a large reduction in energy losses and waste. At the same time, that sort of transformative change is not surprising when you look at how rapidly advancing technologies underpinning the production and use of electricity, including analytics and renewables and heat pumps, storage, electric vehicles, how rapidly they're all advancing, which is to say exponentially. And in turn, those effects, those technological changes have pretty dramatic effects on the grid. No doubt you're already aware of many of these developments, the two-way grid, the prosumers, new business models. My favorite, the highlighted one, is load will follow generation. That's a sea change for the grid. We've been managing supply for over 100 years, and now we're able to manage demand. It's not widely penetrated yet, but there's no technological obstacles. Manage supply and demand? That sounds awfully much like a market. And what happens when a regulatory paradigm designed to reflect the absence of a market finds a market knocking at the door? As we indicated earlier, the situation isn't less disruptive over on the environmental side. Here's an example showing on the left what EPA estimated the U.S. power generation fuel mix would look like in 2030 under the Clean Power Plan. The pie chart on the right shows what the actual fuel mix was in August 2016. Now, fuel mix doesn't equal emissions, of course, and there's still plus or minus 5%, 2% more in natural gas, 2% more in coal. But the direction and pace of change are really evident in the similarities of these two pies. It's not clear that the Clean Air Act is able to keep up with this kind of change. I don't know anyone who's mapped the complexity of the Clean Air Act, but you may recall this schematic of the healthcare reform proposal back in 1993, an era of similar vintage to the Clean Air Act amendments of 1990. And some of the Clean Air Act's inherent and I think unsustainable complexity includes the fact that single pollutants are regulated by multiple Clean Air Act programs, that single programs often regulate multiple pollutants, that controlling one pollutant can worsen emissions of another pollutant or more than one, that air quality standards change regularly. They probably should, but that makes for a moving target. And there's no uniform timetables on when that all happens for which pollutants. And all of this was written with sort of an end-of-pipe orientation in mind, that we'd bolt on technologies onto power plants as opposed to preventative measures like energy efficiency, which makes it more difficult to use the latter in compliance. This all raises the question, isn't there a better way? And indeed, we think there is. State and local governments can't escape public health obligations imposed by the Clean Air Act, and hopefully they wouldn't want to. But they can seize the initiative and take control of the process, do a bottom-up type of approach instead of a top-down federal approach, as long as they stay above the federal floor, federal regulatory requirements. Rather than conducting separate and distinct regulatory processes, utility regulators, environment departments, state energy offices can integrate their work, much like the joint efforts that the Clean Power Plan spurred before it was stayed. Lots of conversations were started as a result of that. States can do that voluntarily. The state's consideration of multiple public health and energy reliability and affordable goals can also be considered together and integrated so that they can be co-optimized instead of potentially conflict with each other. And similarly, co-optimization can happen if you're considering only one pollutant at a time, as we just mentioned, with requirements looming for others just around the corner. eMERGE applies a comprehensive multi-pollutant approach. Finally, state-initiated and controlled processes aren't constrained to specific sectors. Unlike the Clean Power Plan, where emission reductions had to come from the power sector, emissions reductions necessary to meet broad state goals could be secured wherever it's most cost-effective to do so. So the benefits of eMERGE's comprehensive co-optimization and greater certainty would both streamline regulation, reduce regulatory burdens and the costs of compliance, also reduce risk, and those collectively would encourage more and better economic development. In short, eMERGE would put states in the driver's seat. By seizing the initiative and controlling the process, states can explicitly integrate their regulatory efforts with both public utility commissioners, the air or environmental agencies, state energy offices, perhaps in the future even transportation departments. And rather than stovepiped piecemeal approaches, they can comprehensively address the state's regulatory goals: public health, air quality, climate, safe, reliable, affordable, and clean energy, and state policies like renewable energy portfolios, energy efficiency resource standards, and so forth. And they can do all that in a multi-pollutant fashion. We like to think of eMERGE as a Venn diagram, combining the strengths of traditional utility least cost integrated resource planning, shown on the left, and traditional EPA state implementation plan approaches, or SIPs, shown on the right. IRP looks forward and focuses on cost and reliability of the system, but it omits any consideration of public health and other costs that may be borne externally to the system. SIPs, on the other hand, look backward in determining environmental compliance, air quality compliance, and they tilt heavily toward public health versus reliability and cost. eMERGE also adds state energy offices to this mix and includes forward-looking integration of all the goals and engaging all the parties. So how exactly would an emerge process be conducted? Its development is still in the pilot stages, of course, but we've outlined a series of steps which we'll detail now. And I would point out that there, on your control panel, as a participant, you may see a little W with an emerge steps table. That's a document to which I'll be referring. You can refer to it now and return to the webinar, or you can save it. It's available to you, but I'll go through quickly as well. The first step in the process, not surprisingly, is for states to determine their goals. The DEP would identify state public health and welfare goals that are affected by energy-related emissions, specify them in mortality or morbidity, however they want. The PUC would identify state energy goals, reliability, affordability, safety, things such as that. And the State Energy Office would identify goals from a statewide energy perspective. Agencies should also plan for stakeholder involvement, which will be necessary in the implementation stages, if not sooner. It's worth noting that the initiating agency would need to address some logistical issues, such as how best to engage and meet, what kind of time frames the effort will undertake. Planning, of course, has to include what and when, and then what sort of stakeholder involvement should occur when as well. The second step is to identify where you stand now against those goals. For the DEP, the Environment Department, this might be identifying ambient air quality levels or EPA design values for each pollutant. The PUC might identify metrics and existing levels for reliability, cost, risk. And the State Energy Office might identify metrics and existing levels for state energy goals like RPSs, EERSs, treatment of low income, and so forth. It's worth noting that some levels or metrics may not be known, or consensus may not exist yet, so they may need to be jointly determined and developed moving forward as well in the state. The third step would be for all three agencies to determine, does each metric meet the identified goal? If not, then the question is, are there already policies that are on the books that will lead to that outcome, that will cause each goal to be met? And if not, then it needs to be determined what additional work, what air quality improvement, what reliability improvement, so forth, is necessary to achieve each goal. Once again, stakeholder involvement may be useful in this determination as well. The fourth step is to conduct some intermediate modeling if needed. For example, on the DEP side, it may be necessary to conduct air quality modeling to determine the amount of emission reductions that are necessary to achieve the ambient air quality improvement that is sought. The PUC may need to do energy system modeling to determine what resource mixes can achieve least cost planning and reliability goals. And the State Energy Office may need to conduct appropriate modeling to determine ways to best meet the RPS or EERS. Note that economic modeling could also be conducted, but the choice of models is important because, as many of you know, the data and resources needed to support modeling efforts are often themselves significant. The fifth is perhaps the most involved step. Down the road, we hope it'll use system dynamics or other optimization modeling techniques. But at this point, all three agencies, and perhaps stakeholders too, would collaboratively review supply curves, otherwise known as cost curves, to determine energy savings, emission reductions, and co-benefits performance achievable through the most cost-effective measures. We would anticipate that energy efficiency, demand response, renewable energy, and so forth are likely to play a big role. Then the group would rank options by their performance on the metrics on all goals and translate their energy savings into emission reductions. The group would hopefully from that ranking agree on preferred options and compare overall performance to the overall goals of the state, and again conduct modeling to confirm that the goals are all achieved and if not, then iterate until they were. Note too that, as I said earlier, this kind of modeling can be pretty intensive and costly, so we're looking for ways to provide back-of-the-envelope estimates at the pilot stage. In the sixth step, if stakeholders weren't involved previously, they should be now. And if only a limited number of stakeholders were involved in the development stages, the process should probably be expanded to a larger stakeholder set now. And all three agencies would collectively conduct stakeholder processes to determine, so the stakeholders could provide input on what measures should be adopted. This in turn may also lead to revisions and if necessary, iterations in the options and modeling with respect to the state goals. As the seventh and eighth steps are reasonably easy. Once there is agreement and the goals are met by an integrated multi-pollutant package of measures, then it's simply a matter of implementing them. The DEP, of course, would need to ensure that the package that they're talking about is approvable by EPA. Because while states have the opportunity to prepare the programs they would like, EPA has the responsibility to ensure that they would meet federal standards. So it would be good to keep EPA involved, if not early in the process, very much so at this stage, rather than produce an excellent plan that EPA finds fault with. This implementation, once the DEP is cleared, would just proceed through standard notice and comment rulemaking. The PUC and State Energy Office would adopt regulations or policies by conducting standard docket or rulemaking processes themselves, as well as any outreach necessary to implement the measures to achieve the goals. And then finally, there should be a post-implementation evaluation that would identify the process and regulatory streamlining that the eMERGE process enabled, to estimate savings or costs from such streamlining, and sum up those costs and savings across agencies to determine the total benefits and costs, and once again get feedback from stakeholders as well. It's worth noting here that the integrated eMERGE process is likely to be more difficult and costly for any single agency or any single pollutant, but less than for each agency to handle each goal and each pollutant individually. I mentioned cost curves earlier, or supply curves. For those of you who aren't familiar with them, this is an example done by McKinsey of a greenhouse gas abatement curve. As you can see, the lowest cost, and in some cases even negative cost, that is to say savings, options are on the left, and proceed as to the right as they become more and more costly. And the width of each option indicates its scale, as how much it would reduce greenhouse gas emissions. An eMERGE process is likely to consider a number of such cost curves for multiple pollutants and policy goals. With that, I'll turn it back to moderator Nancy and see if there are any initial questions.
Great, thank you, Ken. No, at this point we do not have any clarifying questions, so you and Chris are good to proceed. Thank you.
Thank you, Nancy. I think then it'll go over to Chris.
Great. Thank you, Ken, for that introduction. At this point, our conclusions after we had done a lot of our own analysis were that these processes were indeed similar to what many state agencies do today. The SIP process steps are iterative. They involve a lot of technical analyses, working with stakeholders and other state agencies. But one of the questions that we had in looking at this was, what barriers are there? And one of the first questions was, is eMERGE legal? We're quite familiar with the Clean Air Act, but we're not lawyers. So we asked the Columbia University Law School Center for Climate Change Law in New York City to review the Clean Air Act and to assess whether eMERGE was legal. Their review is summarized on the next slide. So the Columbia University Law School analysis concluded that EPA could not compel an emerge process, but that states have the freedom and flexibility to undertake such a process. EPA has the latitude to review and approve the state-driven emerge processes. And that goes back to the earlier slide that Ken mentioned, that states are really in the driver's seat here. If I could have the next slide, please. Second question is, okay, well, this process sounds interesting and, multi-pollutant and covering economic and energy issues, but where has this been done before? So we, in fact, had the same question. I'd like to highlight two examples in particular here. First, from the one from China that has occurred, and the second from the Bay Area. So if we could have the next slide. So the International Institute for Applied Systems Analysis, or IASA as it's called, is based in Vienna, Austria, and performs a lot of economic, energy, and environmental modeling for European and Asian countries. And they looked at this question to reduce the number of premature deaths in China by 50% over the next 20 years. What would it cost? And they answered this question with two endpoints in mind. First, looking at achieving that 50% reduction in premature deaths through conventional air pollution controls, in other words, end-of-pipe controls. And then the second, with a suite of measures that includes not only end-of-pipe controls, but also energy efficiency measures, increased efficiency at industrial sites, combined heat and power, and those kinds of things. And as you see in these two bars, there's a considerable cost benefit for the suite of measures that includes both end-of-pipe controls as well as those measures that include root of pipe, as we refer to them, energy efficiency and cogeneration kinds of things. Next slide. Second example I'd like to showcase is in Bay Area Air Quality Management District, which regulates air quality for 8 counties in the greater San Francisco area. Their 2010 Clean Air Plan assessed how to meet a number of air quality, hazardous, and greenhouse gas goals over the next many years. And this plan that was developed first in 2010, and it's just been recently extended and revised in 2017, covers not only the criteria pollutants like ozone and fine particle that many people are familiar with, but also looks at meeting both federal and state hazardous air pollutant goals, as well as greenhouse gas emissions. The 2010 plan includes a suite of 55 control measures across all economic sectors. It includes both end-of-pipe as well as root-of-pipe measures. And they also developed their own model to evaluate the public health benefits. So those are two examples of, that have happened recently to show the kinds of processes that we're talking about here under emerge. Next slide, please. So we believe the regulatory environment is timely. Their air quality issues remain. Despite the stay in the Clean Power Plan and change in administrations, we know that half of people in the United States still live in areas that exceed one or more of public health standards. Many states are dealing with ozone, fine particle, regional haze, and SO2 all at the same time. These are very resource-intensive efforts, as those of you who may be in those states know from working. We also have a number of pressing state energy issues. Many state and utility integrated resource plans are in place. And we also have unprecedented rate design issues across the country. We see a renewed interest in regulatory streamlining and reform. So we think that the timing is particularly ripe to consider an emerge process. Next slide, please. Some of the implementation issues that we've evaluated are shown here. We know that, for example, electric vehicle technologies are rapidly evolving. Many states have invested significantly in charging infrastructure. Businesses are also on the bandwagon. They understand that providing free charging at hardware stores and shopping malls, for example, can encourage customer traffic. The Volkswagen emissions settlement is also expected to result in much more electric vehicle infrastructure investment in the states. So that's a significant issue going forward that states are grappling with. Any emerge process will need to be coordinated with EPA. We would recommend that states involve their appropriate regional offices. Those offices liaise with headquarter offices on technical and policy issues, and also are quite familiar with air quality planning processes. The emerge process should also involve stakeholders and the regulated community, just like a traditional SIP process. Also, consistent with initial regulatory efforts under traditional SIPs, one learns by doing and making process refinements over time and benefiting from the earlier steps taken. So we're aware that any initial emerge process will be iterative and informed by the results and success of that initial effort. Right now, I'd like to take a short break and see if there are any questions that have come in.
Chris, I don't, again, we do not have any clarifying questions, so I think you're good to continue.
Okay, great, thank you. Next slide, please. So conclusion slide is the electric power sector is rapidly transforming with new technologies, approaches, and markets. Environmental regulation is changing rapidly with new science, more energy efficiency, more renewable energy. But to date, regulatory processes have changed little. We think that they need to do so, and the emerge process can meet the needs of the future. So I'd like to thank everyone for listening at this point, and this concludes the initial part of the presentation, the formal part. On the next slide, we have additional resources. There's 5 here that we would commend to people. These are all available. In fact, if you simply click on the presentation, you'll be taken to the link to download these presentations directly. I'm now going to turn this over to Nancy.
Great. Thank you, Chris. And actually, we did get one clarifying question right after I said we didn't have any, and it was about slide 26, which, Chris, I believe you were did on, and it was a question about China, reducing depth in China. What does the lightest aqua color represent? I think it's a question about how to read the chart.
The lightest aqua color. Those are end of pipe controls. If I'm reading, I think that's end of pipe controls for NOx.
Okay. All right. Great. Thank you. And Chris, while you have your mic on, here's another one for you, which is what barriers do we see for agencies who are considering emerge? Can you talk a little bit about what some of the barriers agencies might expect to encounter?
Okay, sure. When we were developing the process, we found three types of barriers: institutional, cultural, and technical. On the institutional side, the barriers were the traditional pollutant by pollutant air quality processes and timing and how those synchronize or do not. Looking at end-of-pipe controls versus all options such as renewables and efficiency, for example. And then the third under institutional was that integrated resource plans themselves often omit or do not well consider energy efficiency, distributed resources, and renewables. On the cultural side, we found two main barriers. One I would characterize as, we've always done it this way. We've had, nearly 50 years of progress on the Clean Air Act since it was first issued back in 1970, and there's been a tremendous amount of success. And certainly there's a tendency of humans to like to do things the same way. The second is sort of cultural/political, and we refer to this as not in my term in office. Some of the measures that are undertaken, particularly things like energy efficiency and small-scale renewables, do take a few years to accumulate substantial benefits. And at times, having a political appointee commit to a program in which the benefits will not be realized until that person is out of office can be a challenge. On the technical side, we found three barriers. The first is that evaluation, measurement, and verification, which is known as EM&V, is very well established for energy savings. Public service commissions require this routinely across the country. But we don't see the same level of precision or implementation on the emission side. There are a number of examples, but there's still, I think, not a complete understanding of how those can be calculated and achieved. Second technical barrier is that in some cases there's an expectation that the level of accuracy will approach that of continuous emission monitors, which state air regulators are very familiar with. And then the third is just the fundamental learning curve associated with emerge modeling and assessment.
Okay, thank you, Chris. Actually, Chris, here's another one since it was part of your slides, is you talked about a couple of examples where the process has been tried, at least in part. Are there other examples that you'd like to make folks aware of?
Sure. Yeah, we just wanted to highlight a couple in some detail, but I can mention a couple more. The state of Maryland performed air quality modeling using traditional air models that state air regulators are quite familiar with. And Maryland looked at the ambient air quality benefits from implementing energy efficiency and renewable programs under their Empower Maryland Act. And what they found were benefits to ozone and fine particles, both in Maryland as well as in surrounding states. And that analysis was presented a couple of years ago at a American Council for Energy Efficient Economy, known as ACEEE, Market Transformation Conference in Washington, D.C. Second example I'll mention occurred in China. I do a lot of work in China, so this one is quite familiar to me. And the city of Urumqi, which is in Xinjiang province in western China, performed the cost curve analysis that Ken had mentioned. They determined from air quality modeling that they needed to remove about 82,000 tons of NOx from their airshed by a certain date in order to achieve an ambient air quality standard. So they rank ordered a suite of control measures that included, putting selective catalytic reduction, for example, on power plants and NOx controls on, industrial boilers, as well as looking at energy efficiency. And they, rank ordered those control measures until the requisite level of, 82,000 tons of emissions was removed. And that information was presented about 2 or 3 years ago at a conference. There's also been smaller scale efforts at the city level that EPA has coordinated with the cities of Detroit and St. Louis that have done a similar type of multi-pollutant analysis.
Nancy, this is Ken. I would just add that no place to our knowledge has done the comprehensive emerge process, but as Chris's examples have indicated, there are several areas that have integrated their regulatory approaches better, which is to say gotten their energy regulators and their environmental regulators to work more closely together. Bay Area is a good example of that. Other areas have worked on multi-pollutant approaches like the Detroit one and New York and ESCOM and Maryland, Chris mentioned. And then others have worked on incorporating preventative measures like energy efficiency as opposed to just end-of-pipe solutions. Nobody, to our knowledge, has done all three of those in a bundle, which is what emerge proposes, with the state taking the initiative so that it can get ahead of the federal obligations. Thanks.
Yeah, thank you, Ken.
Great. Yes, thanks, Ken. Ken, while you're speaking, let me do a follow-up that relates to that, and then there was a question about one of your slides. So the follow-up question would be, how do we suggest pitching emerge, given what you were just saying, this approach to an audience or a government and agencies that is not currently so pro-environment or pro-energy at this time?
Well, this is a really good question, I think, Nancy. If anything, I think the opportunity, as Chris indicated, it may be right. This is an opportunity for states to seize control of these elements of their future as opposed to them being dictated to and administered and enforced by a federal agency. So to the extent that current interests may not focus specifically on environment or climate change or whatever, the larger package of the state wanting to get its Energy Act together and avoid future environmental compliance obligations and introduce greater efficiency in their economy, those sorts of goals can be readily met, and so I think that's a good way to pitch it. Another probably obvious one that we mentioned is regulatory streamlining. The nature of regulations, which I referred to as unsustainable in a now 50-year-old Clean Air Act, can and probably should be streamlined. They should be streamlined in a way that protects public health and preserves energy reliability and so forth. But that's where, again, the state can seize the mantle and proceed rather than simply waiting to be told what to do and perhaps not liking it when they are. So I think the pitch here is, let's take control of our own energy future and our own public health future. And Nancy, I should add, we referred to states throughout that, but it needn't be just states. Chris used the example of the Bay Area, which is one of California's air quality management districts, obviously an area that's much smaller than the state. And there's no reason that other programs, counties, even municipalities that have obligations couldn't take a similar approach to those obligations and their energy profiles, even though they're not a state per se.
Great, thanks, Ken. That addressed, I think, most or all of the questions that came in about what could the role of a local agency be in this process, or how they could get involved in a process like eMERGE. Anything else you want to add on that? You covered it, or Chris?
Well, I guess maybe on the local side, the one thing that might be required if a local agency, a city or a county level air district was interested is, in addition to making sure that the EPA regional office was involved, they would also want to make sure that their state was involved, because in most cases there's a state oversight of local processes, even where the local agency has been delegated the authority to regulate and implement and enforce air quality plans.
Great, thanks, thanks, Chris. Ken, let me go back to the one that was about one of the slides you covered, which was the one about the decoupling of energy and environment and GDP.
Sure, I'll try to hop back to that while you pose it.
Okay, so the question is, what was the factor that caused the separation between energy and GDP? It looks like it happened in the 70s. Was it the start of energy efficiency that caused the separation, or do we have other suggestions on what might have initially led to the separation?
There's a lot of theories about that, but it's very, very clear in the data, not only this one, but in EIA data about the annual electricity demand versus GDP growth. And about this early, I forget it was mid-70s period, as the questioner indicated, those two lines crossed, and whereas energy growth had to support a percentage increase in GDP had to be on the order of 2% for a lot of our history, it has declined and is now on the order of 0.8%. And there are a number of theories. One that clearly played is the greater efficiency of devices, and by that I don't mean simply utility DSM, demand-side management programs. That's not what we mean by efficiency in the broadest sense, but whenever anybody, the transition from incandescent lights to CFL, compact fluorescence, and then the subsequent transition from CFLs to LEDs has made about an 80 to 90% difference in electricity consumption associated with that lighting. Similar changes have occurred in variable speed motors and in other energy consumption end uses, and as a result, I think we've seen that change. At the same time, some macroeconomic impacts moving toward more and more of a service economy and less manufacturing probably had a significant impact as well, although that appears to be slowly reversing now that devices and processes are becoming more information enabled and scalable, so that manufacturing is slowly finding its way back to America. So I think there are a number of factors in play, but it is really quite shocking, the change over time.
Great, thank you. Here's a question about stakeholders and involving stakeholders. How would we suggest integrating health and environmental justice issues in cost-benefit analyses? Or do we have some suggestions for that?
This is Chris. On the public health point, many of the models that I'm familiar with have variables on public health impacts of various pollutants and the benefits from reducing them. Some of you may be familiar with a program called BenMap, which was developed by EPA, and it includes default statistics for various morbidity and mortality effects from different pollutants. The users of BenMap can also adjust those data if you have data that from your own state that you feel is more relevant and timely. I know, for example, that they use BenMap now in China, and those data have been adjusted to Chinese level statistics on public health costs. So certainly BenMap would be something that I would include in any type of analyses, and I know a number of states use BenMap now to assess the health benefits. On the environmental justice side, that tends to be a very much of a local issue, and that's certainly where you as a state official or local official would want to make sure that those considerations are brought into discussion, and that folks are included as a stakeholder. I'm lacking any knowledge in terms of default data or things like that you would use, because I think these processes tend to be very localized and not something where we'd have default types of data. But Ken, I don't know if you have additional thoughts on the environmental justice piece from your experience.
Sure, a couple of thoughts, Chris. But great, it's a great question, and BenMap is certainly a good model to include in the modeling that would be done under an eMERGE effort. I think that the involvement of stakeholders generally will depend on the culture of the state. Whether it typically likes to have stakeholders in at the ground floor and throughout a process, or whether it wants to shake some of the cobwebs out first and get it launched, and then bring stakeholder input in is more of a state determination. But one way, of course, that those interests, health and environmental justice, could be brought in is simply to have them participate at either of those stages. So make sure that among the stakeholders that are invited to participate are those sides of the coin. Another is perhaps to include in the goals established by the state some metric or metrics associated with environmental justice. Are there or distributional impacts, or are there particular geographic impacts that could be modeled and determined? That some metric like that may be useful for that concern.
Okay, great. Being starting to be mindful of at least the top of the hour, I want to get to one more question, which I'm going to try to combine two that we got about resources and what's needed to do this process. One was asking, do we know of states who currently have the resources and the expertise to undertake this process, and what would it take to get that expertise? And a related question was the skills that are needed to project energy demand and supply is different than those doing air quality modeling. And the question was framed as, what do we suggest for helping these folks work together and in the one process rather than sequentially?
Yeah, that's a really good question, and because no location has done the full soup to nuts, we can't answer it precisely, of course, at this point. But I see this, given the resources constraints that states typically operate under, as being sort of an expanding concentric circles, where one can start the process with many of the early elements. What would the goals be? Getting the players together, perhaps involving stakeholders, determining current status, and so forth. Those are all fairly low cost items. The costs start to accrue when one wants to prepare or secure cost curves and then proceed with the analytical bases and modeling. Most of the states have modeling capability within their air quality departments associated with pollutant impacts and what emission reductions will yield in terms of ambient air quality improvements. Most PUCs probably do not have energy modeling capability internally, but most of the utilities they regulate do, and assuming that they can enlist those utilities in the process as stakeholders, that would be a good way to provide much of that. Now, there's still the problem of combining all of these goals and determining optimal solutions across the board. And as I said, ideally that would be a systems dynamics kind of approach or some other grand optimization scheme. And to have that automated would be pretty sophisticated and expensive, although I don't think it's more expensive than some of the other major models that even EPA currently employs, like the MOVES model for the transportation sector, or some of the power sector work that it does with the IPM model. So I think that those are achievable, but they would be a definitely second, third stage, bigger concentric circle after the concept is proven out at more back of the envelope kind of calculation stages. So in the early stages, I would suggest that that optimization would occur through meetings and deliberation of the principals and stakeholders rather than through sophisticated modeling. What the actual price tag will be, of course, is not clear at this point.
Yeah, if I can just add to Ken's fine remarks, I would also, I guess, compare the resource commitment to eMERGE to what states are already looking at today from the existing processes. One of the states that we talked to looked out over the next, I think it was 10 years on an annual basis, and found that there were 6 different air quality programs that they were going to be on the hook for revising. They have a regional haze issue, they've got an ozone issue, they have a fine particle issue, they've got an SO2 issue, and there was some kind of local toxic issues. And the question that poses itself is, each one of these processes, as we know, under traditional SIP metric, is quite intensive. And does it make sense to do 6 individual processes, which actually may have to repeat them in a couple of years? Or why not look at this holistically up front and say, okay, what kinds of things can we do that satisfy all 6 of these requirements at the same time, or at least many of them, and in fact, the resources could be much more efficiently used, and certainly you would gain the cooperation and coordination with folks on the energy and economic side as well. So that's one real example that's out there that gets at this resource question.
Chris, we're very close to the 3 o'clock, to the end of the hour, and so I want to thank those who've asked all the great questions. We have a number more we can answer, so we will stay on the line for up to an additional 30 minutes for those of you who would like to stay on if your time allows. But Chris, I'm going to turn it back to you to leave us with a few closing remarks in the 2 minutes we have left.
Okay, well, first I want to thank everyone for participating. This is, I know, new to many people, but what we really want to show here is that the process itself is trying to be familiar to states in terms of the SIP processes that they're already have been using, the fact that they're using the stakeholders and the EPA coordination, and certainly many states do coordinate already with their public service commissions and energy offices. So this is the type of message that I think is important to looking at eMERGE. The second point is that we think having states in the driver's seat and basically, writing their own ticket and being flexible should be attractive. Most states that we work with like to be in the driver's seat, and certainly that was the case when, Ken and Nancy and I were state regulators ourselves. We like to develop our own programs, and certainly the flexibility piece is part of that. But then the third is getting beyond what we think can be an often iterative and resource-intensive SIP process, to be able to step back and say, okay, what are my public health goals? What are my energy goals? What are my economic goals? And how can we look at those in a way where we optimize all three, and do so with, acknowledging that there are constraints, but addressing them through a process where everybody has a say. And that's, I think, the important take-home message that we'd like to leave with folks. And last, this is not an emerge point itself, but just in terms of where do we go from here, we are open to talking with states. You have our contact information. Nancy, maybe put up that slide. There's Ken and my phone number and email. Please feel free to call or email us. We would entertain, any kind of a conversation. One of the things that RAP does is we're really good at maintaining confidentiality. So if these are just things that you just want to bounce off, we're happy to do so, and of course would never attribute remarks to any particular state. We use what people often call Chatham House rules, where we might say that a state said X, but we would never identify what that state or local agency was. So I would encourage folks to reach out to us, and we'd be happy to entertain any follow-up conversations or meetings with you or others in your state. So thank you again for participating.
Chris, I want to thank Chris and Ken for their great and informative presentation. We're going to conclude the official portion of the webinar now. So thank you for spending part of your time today with us. And for those of you who would like to stay on the line, we have some other questions we will stay on to answer. So please join us if you can. But if not, thank you very much for joining us, and we hope you'll join us again for another webinar soon. Okay. So Chris and Ken, let me go to a question that asked a question about preparing energy plans and the schedule for doing those. And what do we think about coordinating the schedule for those plans with the preparation of a SIP? So I guess it's a question of, what's our experience with states with energy plans, and how does their timing coordinate with timing for SIP?
That's a great question. The state energy processes and integrated resource plan processes tend to be driven through public service commissions. Some of those, and I should also point out that not every state requires IRPs. A majority of states require an IRP or something like an IRP, but not all 50 states require energy plans. So that's a caveat. But it's kind of I guess it's sort of all over the place, as you might expect. In some cases, there's legislation that dictates the timing of this, that IRPs or state plans are to be submitted every year, every 2 years. But in other cases, that's more of a public service commission decision. And in those cases, or in cases where there is no timing, I think that's where one could look at synchronizing or better synchronizing the energy planning with air quality planning, where there's not a statutory hook that dictates a requirement for submitting a plan.
I think Chris has characterized that just right. The only thing I would add is it's not just a matter, of course, of working energy plans into a similar schedule as a SIP, but also multiple SIPs. Chris earlier enumerated the number of air quality issues facing one jurisdiction. By getting ahead of the curve, the state can really avoid facing SIP calls because they're in compliance or in attainment. And so avoiding that mess by virtue of determining your own comprehensive schedule as opposed to the EPA and other regulatory piecemeal schedule is part of the tricks that emerge offers.
Okay, great. The next question was sort of generally about what do we see in terms of the accuracy of these models? Do we have anything we'd like to say about that?
I'm not sure, of course, which models are being directly referred to. The models we've generally referred to are ones that are already well used, diffusion models and so forth on the air quality side. Emission modeling is approved by EPA for SIP purposes, you know, and how air pollutants are dispersed in an airshed and so on. Energy models are also pretty reliably used by commissions. All modeling, like all planning, is never correct, but without it, one's pretty much at sea. If the question refers more to the co-optimization modeling that we would eventually like to see, obviously we can't answer that at this point because those models haven't been built. But I think that ultimately when they are, they too will suffer from never being completely accurate, but always being helpful and in the right vector direction.
Yeah, I guess I'd like to add a little bit to this because this question about precision came up as a barrier. And if you're familiar with continuous emission monitoring and the audits required, you'll know that when they do the quarterly tests and then the annual tests, the monitor is supposed to be accurate within a certain degree of precision. That's plus or minus 15% typically. Although in some cases they have strengthened that precision, and some states require more precise, but the federal requirement typically is plus or minus 15%. What we've seen on the energy efficiency side, which is a question about, you know, how accurate are energy savings, is that precision has also improved quite a bit over time, and the data, especially where there's a state oversight process, is quite rigorous, and we see you know, the audits done on efficiency that are at least as precise as those on the continuous emission monitoring side. And then certainly for renewables, that precision is often just a straight generation output, which would have precision similar to that from a power plant. So we have seen a lot of improvement in data and its precision, and there's also, you know, new evaluation, measurement, and verification techniques and even process models that are being developed that will increase that precision over time.
Okay, great. Thank you. Here was one that was more of a comment, but I'd like your reaction to it because I thought it was a good one. And so it goes, the air toxic section of the Clean Air Act departed from a chemical by chemical approach and moved to a technology standard backed by health-based standards, you know, the risk, residual risk approach. So it's, the person's comment was this is not a pollutant by pollutant approach, you know, more of a technology approach. And sort of, so my question to the two of you is, do you have a reaction to that comment? How do you see that or air toxic regulation maybe working with eMERGE, which is geared to industrial sources, of course, not the power sector generally?
Well, I think this is a great opening, Nancy, and the commenter is quite correct. And the friendly modification that I would suggest to the toxic process is that in the assessment of technology and residual risk, that the facilities not only be required to look at end of pipe measures, but also to look at, within the premise itself, what types of process changes they could make to improve how they manufacture a product, how energy is consumed on site. This type of premise-wide view would reveal additional energy savings, as well as perhaps changes in design that would also be quite effective at reducing hazardous pollutants, and of course, to the extent that there's criteria pollutants there, those benefits would be revealed as well.
Nancy, I would just add that Chris and the questioner are exactly right, and to be accurate, I think our thinking on toxics has been along the lines Chris just described. It has not been front and center with respect to issues that were principally and initially driven by power sector and criteria pollutant concerns. We think that, as Chris indicated, that toxics can be well incorporated, but they shouldn't be the starting point, and so there may be some additional complexities along the lines the questioner raised.
Okay, thanks. So let's, I think, unless something else comes in, we'll take this last question, which goes back to resources, but also and process. So given that we all know that state agencies are strapped for resources and staff and getting things done, what do we see as an initial first step that a state agency staffer could take, and without sort of expending a lot of resources up front? What would we suggest that people do first if they're interested in this process?
Another excellent question. I think that the costs needn't be great to start. They would be primarily existing staff looking at existing problems in a somewhat different way. As Chris mentioned, there may be the need to undertake parallel processes for a bit while this one is being piloted. But I think the first step is simply to have that agreement either by virtue of the agencies in the state already being combined and it being of interest to that agency management or governor's office, or having them work closely together in a process that echoes that consolidation, that kind of collaboration. But the best first step, I think, is simply to have that interest, give us a call. Let's start doing some of that initial legwork, and then overcoming obstacles as they arise in a pilot program. It may be possible that that philanthropic funders would also recognize the benefit of this approach and provide some additional support for state processes, at least in the pilot stages of proving the concept. Thank you.
Yeah, I think Ken has had that's an excellent assessment, and I would just add that this amplifies what we mentioned earlier, that coordination with the EPA regional office is important, because the question about syncing with SIP deadlines is something that the region is quite familiar with. And it may be a case where you're looking at a few month delay, for example, in submitting a traditional SIP versus doing something like eMERGE. That's the kind of discussion that a state can have early with EPA to get a read on, how is that acceptable? What would be the parameters of that? And my sense is that to the extent that a state coordinates well with EPA, and that the outcome that they're looking at would be achieving the same or better environmental result, then I think a time frame short time frame like that is something that I think could be discussed, and that gets into the flexibility piece.
Good point. Good point, Chris. Yeah.
Okay. Well, that does it for the questions. Thank you so much, Chris and Ken, for all those insights and expertise in answering on the fly. I want to thank everybody who remained on the line after for this sort of add-on session, and to let you know that a recording of the webinar along with the presentation will be available on the RAP's website and will also be sent to you by email tomorrow. And we hope that the rest of your day goes very well. Thank you, everyone. Bye.
Thank you, Nancy.
Bye. Thank you, Nancy and Ken.